In this module, we will talk about the sterilization kinetics. So when we say a contamination, we cannot say that that is only contaminated with one kind of the organism. That may contain a number of kind of the organisms. Some are very resistant, some are less resistant. So in our later slides, we will discuss step by step in each situation. So if our contamination is with mixed culture, and that have the, we can say that different effect of the heat treatment, then we can say their sensitivity to the heat is different than in first case. If we say that there is a whole culture and then that contain the sensitive organism and some resistant organism. So in this graph, we can see easily, you can see here there are three different lines. One is dotted line, and other is a solid line, and third show the resistant organism, the dot, as you see that. So in first case, when we have a graph between the ln with the t time, we can say that the whole culture have basically the average of that. As concerned the sensitive, the effect of the heat is very strong effect, but on the resistant organism, the effect of heat is less as compared to the sensitive one. These are cases only when we are dealing with the heat sterilization or moist heat sterilization. So in next case, when our culture is only when we can say that have a most resistant population in the fermentation medium. So in this case, you can see that the whole culture, sensitive organism and the resistance organism. As concerned the resistant organism, you can see here what is the status. So as concerned when most of the contaminant are the resistant, then this kind of the relationship we can see after the heat treatment. In third case, when we say that if we are dealing with any first order reaction, the reaction rate increase with increase in the temperature. So when we increase the temperature, that directly affect on K, then that increase the death rate. So in such, when the reaction rate constant, that can only when there will be heat is constant. So in case of the destruction of the microorganism, the specific death rate is show the relationship of the heat treatment and the death rate. So when we are dealing with the relationship of the temperature with the reaction rate, so the heat treatment, temperature treatment and the reaction rate, so this equation which we call as the Arrhenius equation, so the relationship of rate of reaction, death rate and the temperature, we can have the relationship here that can be easily demonstrated by Arrhenius equation. d ln K over dt is equal to E over RT square. Here E is the activation energy, R is the gas constant, T is the absolute temperature. So when we take the integration of this equation, then we have this equation, K is equal to A E powered by minus E over RT, where the A is the Arrhenius constant. So when we take the the natural logarithm of this equation, then we have this equation, ln K is equal to ln A minus E over RT. So if we plot the graph between these two, then we can say it may be seen that the plot of L and K against the reciprocal of the absolute temperature, that will give a straight line. So such plot between the reciprocal of the temperature with the log of nature of the rate constant, that is known as Arrhenius plot. By this way we have a straight line, so that can be enabled to calculate the activation energy and the prediction of the reaction rate. So by just plotting these two, we can predict and we can estimate the temperature at which we can achieve the suitable sterilization of the fermentation medium.